Okay, so here our question is, how do we find the distance from the origin to point Z1? That is also called the absolute value of the point. And basically, it's the length in real life of that segment in the units on the coordinate plane. So basically what we've done when we've drawn this is we've created a right triangle that has as its length segments, as its side lengths, 3, because we're going 3 over from 0, and then we're going 4 up. So the length of the segment is the square root of 3 squared plus 4 squared, which is just equal to the square root of 25, which is just equal to 5. So this segment has a length of 5, and that is the absolute value of 3 plus 4i. So notice that we did not include the I when we did this calculation here. All we included was the real value here and the coefficient of I here. And then the absolute value of 3 plus 4i is equal to 5. Notice that for any number that's along the real number line, here or here, the absolute value will just be like it is sort of in the way we've calculated in the past. That is to say, we just take if it's a positive number, we just take the value. If it's a negative number, we just take the opposite of the value. So again, but those are all just measures of the distance from the point to 0, 0, and certainly along this axis, the number 4i would have an absolute value of 4. So we can find the absolute value for any point in the complex plane using this method. Okay, so now we're asked, well, how do we find the coordinates of points such that the absolute value of the point is equal to 1 and a is equal to b? So basically what we're saying is that we could rewrite this as a plus ai, since a is equal to b, and that means that the absolute value is equal to a squared plus a squared, the square root of that, and that has to equal 1, which means that squaring both sides, we get a squared plus a squared is equal to 1, or 2a squared is equal to 1, which means that a squared is equal to 1/2. A is equal to the square root of 1/2, which is also equal to the square root of 1 over the square root of 2, which you can rewrite as 1 over the square root of 2, or multiplying top and bottom by root 2, we get square root of 2 over 2, and that means that a and b are both equal to square root of 2, so we get the number square root of 2 over 2 plus square root of 2 over 2i is a number that has an absolute value of 1, and a is equal to b. Alternatively, we could have had negative root 2 over 2 minus root 2 over 2i, and that would have been back here when we found the a was equal to the absolute a squared was 1/2, so a really would be equal to the positive or negative square root of 1/2. Okay, so now we're multiplying z1 by the point we found in number 2, and going back we see that z1 is equal to 3 plus 4i. So what we're doing is we're multiplying 3 plus 4i times, we'll use the positive version, root 2 over 2 plus root 2 over 2i. And that's going to give us, so we're going to end up with 4 multiplications. So we have 3 root 2 over 2 plus root 2 times 4i over 2 plus 3 root 2 over 2i plus 4 root 2 over 2i squared. All right, so let's do a little simplifying here. So we take the terms that have I. We have root 2 over 2 times 4i, so the 4 and the 2 cancel out. We end up with just 2 root 2i. And then we have over here still 3 root 2 over 2i plus 3 root 2 over 2i, which ends up giving us, this is really 4 over 2 root 2i, so we end up with 7 root 2i over 2. And then for our real portion, we have 3 root 2 over 2 That comes from here, and then from here, the I squared gives us negative 1, so we end up with negative 2 root 2. And so when we add these together, we get negative 1/2 root 2I. So our number then is 7 root 2 over 2 minus 1/2 root 2I. Okay, now we want to find the absolute value of this point here. Well, we're going to get the square root of 7 root 2 over 2 squared, and then plus negative 1/2 root 2 squared. And we want the square root of that, so we're going to end up with the square root of 49 times 2 over 4 plus 1 times 2 over 4 is going to end up giving us the square root of 100 over 4, which is going to give us the square root of 25, which is equal to 5. So the absolute value that we got here is equal to 5, and that's the same absolute value that we had for the point z1 originally, which is not surprising because when we multiplied by this value of this number here, the root 2 over 2 plus root 2 over 2I, remember that was a number that had an absolute value of 1. When you multiply two numbers, two complex numbers, the product's absolute value will be equal to the products of the absolute values of the individual numbers. In other words, if we have, so the product of A plus BI times C plus DI, the absolute value of that is equal to the absolute value of A plus BI times the absolute value of C plus DI. Okay, so let's continue here, and we will go on to our next page and take a look here. Okay, what are the coordinates of 5 other points that have the same absolute value as z1 but do not lie on either axis? Well, basically what we're saying is they have to be on the circle that lies at a distance of 5 from the center point here, 0, 0. We already have 3 plus 4i, so, but we can go around and we can say, all right, we're going to also have 4 plus 3i. We're going to have 4 minus 3i. We're going to have 3 minus 4i. We're going to have negative 4 minus 3i. We're going to have negative 3 minus 4i. Not surprisingly, we're going to have negative, over here, negative 3 plus 4i, and then again, negative 3, negative 4 plus 3i. So we have 8 points just by exchanging the A and B values and by taking their negatives. We could also obviously have found a lot of other points on the circle, all of which would have had an absolute value of 5, because again, the absolute value is just the distance from 0, 0 to the point, and since they all lie in this circle, they're all going to have the same absolute value. Okay, what complex number, z, is such that z squared is equal to negative 5 minus 12i? All right, so let's say that z is equal to a plus bi, which means that z squared is equal to a plus bi squared, which is equal to a squared plus 2abi plus b squared I squared. So from here now we can say therefore b squared I squared is going to give us a squared minus b squared. So now we have that a squared minus b squared, which is the real portion of our complex number, has to equal the real portion of the right side here, or negative 5. We also know that our imaginary portion, 2abi, has to equal the imaginary portion of this number, or negative 12i, which means that 2ab must equal negative 12, which means that AB equals -6. And we can keep going and say, therefore, that B is equal to -6 over A. What that means is that we can replace B with -6 over A, and we get A squared minus -6 over A squared is equal to -5, or A squared minus 36 over A squared is equal to, well, actually we'll add the 5 to both sides. Plus 5 is equal to 0. Okay, let's multiply through everything by A squared, so we end up with this, A to the 4th, and we'll just move the 5 here, plus 5A squared minus 36 is equal to 0. Well, this is factorable into A squared minus 4 times A squared plus 9 is equal to 0, which means that A is equal to 2 or -2, but it also means that A could be equal to 3I or -3I to make this second term here equal to 0. Okay, so that means our complex number, and we have a variety of them, is either going to be A is equal to 2 and B is equal to -6 over A, so that would give us 2 minus 3I, or we could have -2 and positive 3I, or if A is equal to 3I, that's actually going to make it the imaginary portion, and if we take B is equal to -6 over 3I, that's going to give us -2 over I, and that's going to end up giving us a value here of, this is negative, of positive 2. So we'll end up right back where we were here. So we end up with 2 minus 3I and -2 plus 3I as our two values that are the square root of -5 minus 12I. All right. What is 4 minus 3I raised to the following powers? All right, let's do out the multiplication. All right, 4 minus 3I squared is going to give us 16 minus, so we have 3I times 4 and another 3I times 4, so it's going to give us minus 24I, and then it's going to be plus 9I squared, which is going to give us -9, so we're going to end up with 7 minus 24I. Okay, we're going to be asked about the absolute value of this later, so we're going to calculate that now. 7 squared plus -24 squared is equal to the square root of 49 plus 576 is going to give us 625, or it's going to equal the square root of 625, which is equal to 25. Okay, now when we multiply this by 4 minus 3I again, we have 7 minus 24I times 4 minus 3I. That's going to give us 28, 7 times 4, minus 21I, minus 96I, and then plus 72I squared, which means that we'll end up with -72. So what we end up with is 44, which is 28 minus 72, minus 117I. Now when we find the absolute value of this, we're going to get 44 squared, and then plus the square root, negative 117 squared, and what we're going to end up with is a number that's equal to, when we take its square root, 125. So the absolute value of this thing is going to be 125. Okay, one more time. So this is really just 7 minus 24I times 7 minus 24I, which is going to give us 49. Minus, so 7 times -24 is 140, 168, doubled is 336, so we end up with -336I. And then -24 squared is 576, so we end up with plus 576I squared, or negative, so we end up with 49 minus 336i minus 576, which is the same thing as saying 527 minus 336i. When we take the absolute value of this, we're going to end up with 625. Each time we're multiplying, we are increasing the value of our absolute value by 5. And that makes sense because that's the absolute value of 4 minus 3i. And so we're just increasing the absolute value of our products each time by a factor of 5. Okay, that's all we have for this.